Let's set the scene. We're on a massive 1,000-hectare farm. It's in the Limpopo province of South Africa. It's remote, it's dry. Out here, you are completely on your own. There's no power grid, no city water. Your survival and the survival of your livestock depends on every single drop of water you can find.
And when I say off-grid, I mean completely off-grid. All the power comes from the sun, and every drop of water gets pumped up from deep underground. It's a totally self-sufficient system, but that also makes it incredibly fragile. At the very heart of this whole operation is a huge water reservoir. We're talking 180,000 liters. That's not just a water tank. It is the lifeblood of the entire farm. It's everything. Now, try to picture this. That entire 180,000-liter reservoir drained completely dry over a single weekend. And then, as if that wasn't bad enough, it happened again. A total catastrophic loss of water that put every single animal on that farm in danger. So what on earth went wrong? How could something so simple lead to a disaster of this scale? Let's break it down. You know, this line from the project report just says it all. Can you imagine the sheer panic? The farmer drives 30 kilometers to get to the farm on a Monday morning, only to find the cattle's water troughs are bone dry. In a place this arid, that's an absolute crisis. And the causes? Well, they're almost ridiculously simple. The first time, it was a troop of baboons. They literally just opened a tap and walked away. The second time, some cattle got into a fight near a trough and snapped a pipe. In both cases, the result was exactly the same. The entire reservoir just emptied out, and nobody had a clue it was happening. So you might be thinking, okay, why not just fix it? Why was this such a ridiculously hard problem to solve? Well, the farm's unique situation created this perfect storm of challenges. For starters, being off-grid means you're running on limited solar power, so you can't just plug in anything you want. The farmer lives 30 kilometers away and only comes out on weekdays, so a leak on a Friday night, it goes completely unnoticed until Monday. Plus, the mobile signal is terrible. And here's the real kicker. It takes a day and a half to refill that reservoir. That means the animals would have no water until Tuesday afternoon, at best. So, with all of those constraints, how could technology possibly solve a problem caused by, well, by baboons and brawling cattle? The answer was pretty brilliant. Create a smart water network. And the solution here is the Internet of Things, or IoT. Now, if that sounds complicated, don't worry. Put simply, it's just a network of smart gadgets that can sense what's going on, take action, and call for help, all by themselves. Think about it in 4 simple steps. First, you've got the smart things. These are the sensors and valves out in the field that can feel and act. Second, you need a network so they can talk. Third, you need a brain in the cloud to make sense of it all. And finally, you have the application, the voice that sends an alert straight to the farmer's phone. Okay, but building a system like this for such a harsh, remote place, that means you have to make some really specific, really smart engineering choices. It's all about picking the absolute right tools for the job. So, the first big question is, how does the system even know there's a problem? How can it tell the difference between normal water use and a catastrophic leak? It all comes down to the sensor. The engineering student behind this project made this fantastic grading table to figure that out. They compared a bunch of different flow meters, looking at everything from accuracy and ease of use to how well they handled particles in the water. But the big one? Cost. As you can see, while others were good, the turbine flow meter just hit that sweet spot. With a top score of 38, it gave the best all-around performance for the money. Okay, so the system can sense a leak. That's great. But just knowing there's a problem is useless if you can't do anything about it. So the next critical question is, how does the system physically shut off the water? They looked at 2 main options, a solenoid valve and a motorized ball valve. A solenoid is super fast, but it's a total power hog. It needs constant electricity to stay open or closed. That's a huge no-no for a solar-powered system. The motorized ball valve, on the other hand, only uses power when it's actually moving. Plus, it closes slowly, which prevents a damaging pressure surge called water hammer. For an off-grid system, it was the clear winner. All right, so we can sense a problem and we can act on it. What's the final piece of the puzzle? Communication. How does a smart device in the middle of nowhere with basically no internet call for help? Well, a detailed study of the area's network coverage was done, and you can see the results right here. While tech like LoRa is great for some things, based on the actual network maps for this specific farm, good old GSM, yeah, the same technology our phones use, offered the most reliable coverage. It was the top choice to make absolutely sure the alert gets through. So, now let's put all those carefully chosen pieces together. We can finally look at the complete blueprint for this smart water guardian. At its core, you've got the brain, an ESP32 microcontroller. It's a tiny, powerful chip that processes all the data and makes the crucial decisions. The brain gets its information from the system's senses, that turbine flow meter we picked, which is constantly feeling the pulse of the water network. When the brain detects a problem, it sends a command to the muscle, the motorized ball valve, which physically closes the pipeline and stops the disaster in its tracks. And at that exact same moment, it uses its voice, the GSM module, to shoot a critical alert straight to the farmer's phone, letting them know exactly what's happened. So, what's the big takeaway here? This whole project is about so much more than just one farm in South Africa. It's really a blueprint for a more resilient, smarter, and safer way of farming, especially in places all over the world where water is precious. And that leaves us with a final thought, and it's one I really love. This entire life-saving system, it was designed as a final year university project. So, if one student with a few carefully chosen gadgets can solve a crisis like this, it really makes you wonder, doesn't it? What other huge, real-world problems are out there just waiting for a small, smart solution?